Okay, so these histograms and box plots are really useful, but for this particular data set, they're perhaps not so useful because what we can see, what we've already seen in the data when we looked at the line plots, when we looked at the time series, the spread in these variables may come from trends over time, and these histograms and box plots tell us nothing about time. They're just telling us about a collection of values. So spread might come from trends. So if you get a something like one of the products that's selling nothing at the beginning of the year and then goes up suddenly, you'd get a very wide spread because it's going very rapidly. But the histograms and box plots don't really tell us that. And if you recall from last week, it looked like some of the products had regular seasonal peaks and troughs and fluctuations, as I mentioned at the beginning. And this is known, when it can be detected, is known as seasonality or periodicity or periodic behavior sometimes. And of course, it can arise in various ways. So if you think about temperature, that's an obvious one. Temperature is regularly colder in the winter and hotter in the summer. The food might actually follow that. So as we mentioned about ice cream, when we're talking about correlations, ice cream sales might be higher in the summer. Might sell more, I don't know, soup in the winter. Some products are seasonal with regard to the week. So you might sell more certain types of food or alcohol higher at the weekend. And regular events can also impact on sales. So for example, if you have a store that has a regular promotion, maybe a sale regularly at the beginning of summer, or it has a catalog that it lets out, launches regularly, or it has clearance sales, those are going to affect the sales of certain products as well. Remember, we're not looking at prices here, we're just looking at the number of items sold. So they can be changed dramatically by having sales and promotions. So how can we look at those things? Well, first of all, let's remind us what the time series looked like for all products. So this example just uses these subplots to draw the line plots of all 25 products. Okay, so we haven't done this before, but it's quite straightforward to do. So the loop, the subplot for each subplot is created by just plotting the data index, the dates against that product. So that selected product, I've set the line width a bit narrower to show it up, to not overwhelm. And then just for the sake of making this picture reasonably clear, I've set the tick marks along the bottom to be empty. So this second line here removes the tick marks on the x-axis because otherwise there's just too many of them. That's the dates, right? But what you can see there, you can see definite suggestions of seasonality. So regular seasonality, particularly in product A up here, product J here, product S. This looks like, so if you think there's 4 peaks there or 4 troughs in all of them, that looks like some sort of quarterly seasonality, which perhaps is a bit unusual. And don't forget that these products, it's all fictional data. Seasonality is more likely to be annual, in which case you'd really need to see the whole, several years worth of data to spot something like this, or it might be weekly, in which case there's not enough, there's too much information here. You probably don't want to see a smaller length of information or a bigger chart in order to detect those visually. Okay, but let's see what we can do to detect those things using a technique called autocorrelation plots. And one way, these are a way of exploring seasonality, this idea of autocorrelation. And it's a very smart idea, actually. So the idea is this: suppose you've got a time series that's got regular weekly peaks, say on a Saturday. So maybe it's something that sells particularly well on a Saturday. Suppose we measure the correlation between the time series and itself, but a week earlier. So we take the time series starting on the 1st of January and the time series starting on whenever it is, a week earlier, 25th of December. Or maybe 2 weeks earlier, so the 18th of December. If there is a weekly, peak every Saturday, then the correlation between the time series and itself a week earlier or 2 weeks earlier should be very high. You should get a high correlation because the peaks will be in the same place. Okay, so if we correlate the two time series, but offset by a different amount of days, then we should get peaks in the same place, you know, because it's every Saturday, but those things will line up if we choose to do it on a weekly basis, and so we'll get a high correlation coefficient. And so autocorrelation it takes this idea one step further, and it measures the correlation of a time series with itself for every possible lag. So if you imagine you've got a time series of 365 days, it would measure the correlation of a time series with itself with a 1 day lag, and then with a 2 day lag, then with a 3 day lag, then 4 day, and so on. You can do autocorrelation in Matplotlib, but actually Pandas has a higher level of visualization to do autocorrelation, so it's easier to interpret. So we're going to use Pandas to do this, but it's based on Matplotlib. So in order to do this in Pandas, what do we need to do? Let's start with product A, which we know, or we can see, has got some sort of regular seasonal feature. What we do is we do an autocorrelation plot with Pandas. So PD for pandas.plotting.autocorrelation, and then we pick the A column, data A, and then we just draw that. Okay, and we put the title product A autocorrelation. And in order to measure the seasonality, you look at the second largest peak. So the initial peak here, this first peak is for the time series correlated with itself. And of course you get almost perfect correlation with when the time series is correlated for itself. I think we don't actually see that. I think that would be, that would be up here. If you correlate a time series with itself with no lag, then you get perfect correlation. So we're not seeing that. We've chopped off the edge of the graph. So what we're looking for is the second peak. Okay. And the secondary peak, if you look at it, it seems to be, if you measure up to there, it's about 90 days. So roughly this time series has quarterly seasonality. So every 90 days, there's a peak in the correlation. Remember, this is the lag. This is the number of days that we're lagging one time series behind the other. So the peak of the correlations comes when we look at a lag of 90 days, which means that the time series is correlated with itself, but 90 days earlier, and that means that there must be some sort of quarterly seasonality. But this peak has to be high enough so that we can actually measure it. Okay, so if everything is between the dashed lines, then we say it's not statistically significant. So if I draw these autocorrelations and they fall between, the peaks fall between the dashed lines, then it's probably not a correlation. It's just some noise in the data. Okay, so then we can take this. Actually, no, I'm going to stop there. I'm going to finish that. That's the idea of autocorrelation. Then let's go on and explore that in all our time series. So I'll finish the video there, and we'll take this a little bit further in the next video.